Very good morning, students. For this lecturing video session, I'm going to solve a problem from support reactions. Let me just read out the question first. Determine the reactions at supports P, Q, T and V for the beam subjected to loading as shown in figure. So in the previous problems, if you notice it, there will be there was only one beam, isn't it? Which is supported by two supports. Either it would be roller support or the pin joint, isn't it? So look at here. Here there are even two beams, and between beams there is a support. So this is quite different from the previous problems. Now just observe carefully how I am going to solve these problems, right? So before drawing the FBD, so you'll have to convert first the UDL or UL that into point load, isn't it? So let me just convert that UDL into point load. So the point load equal to W into L, isn't it? So the W is nothing but the intensity of the load, that is the UDL, so which is 10 into the length, that is the span of the UL, which is 2, which is equal to 20 kilonewton. Got it? So then now load acting point for that load is equal to L by 2. L is nothing but the total length of the UDL, which is 2 meter. So 2 by 2, which is 1 meter. Got it? Now I am going to draw the FBD. See, as far as this diagram is concerned, so since it is two beams are there, so I need to draw two FBD. So let me just draw the first FBD for this the small beam, wherein the V point at V, I have a force, that is I have a support which is hinge support, which will have two reactions, isn't it? So which will have vertical VV and its horizontal HV. Let me just extend this beam here, and look at here, this is a roller support which will have one reaction, which will have vertical reaction, so which can be taken as VQ, and the point load or the concentrated load which is acting at point U, right, at U, which is inclined, right? So this needs to be converted into two components, that is the vertical component and the horizontal component. So the vertical component can be 30 sine 30, and its horizontal can be mentioned as 30 cos 30. Got it? It's horizontal. Now mention the distance. Distance between V and U is 2 meter, and from U to Q, which is 1 plus 1, which is 2 meter, right? So now I have completed the FBD of 1. Let me just move to the FBD 2. So which starts from here, right? This is a roller support which will have at point P, which will have one vertical reaction, which is VP. Got it? Let me just move to the next point. Let me just extend this beam till last, right? So let me just take this point Q. So this roller support, right, this is a roller support, therefore there will be a reaction which is perpendicular to it, so which will act in this manner, so of VQ, and the UDL has been converted into point load, right? So this is R, and at S, a load which is acting, that is 25 kilonewton. Got it? And this, look at this UDL has been converted into PL, which is also acting at the same point, that is 1 meter from R. So this can be mentioned as already, it is 20, right? 20 kilonewton. 20 kilonewton plus this 25 kilonewton. And at point T, so hinge support or the pin joint support, which will have one vertical reaction that is Vt, and it has a horizontal reaction too, that is Ht. Now I need to specify the distance between each points. So P to Q it is 1 meter, 1 meter, and Q to R it is 1 meter again, and R to S is 1 meter, and S to T is also 1 meter. Got it? So now from where you have to start? So first you have to see the unknown, number of unknowns here. Here 1, 2, 3. 3 unknowns are there as far as FBD1 is concerned. Look at here. 1, 2, 3, 4 unknowns are there as far as FBD2 is concerned. Where to start? As I taught you in the first unit, when I used to solve the resolution of forces, so where you have the minimum unknown forces, that is the reaction, that is action and reaction problems. When I used to solve, I used to highlight that, right? Where you have minimum unknowns, from there we'll have to start. So I'm going to consider the FBD1 because it has only 3 unknowns, right? I'm just considering beam 1, that is FBD1. So now applying, again you'll have to apply the equilibrium condition, so which is summation H is equal to 0, summation V equal to 0, and sum of moment equal to 0, isn't it? So now let me just consider summation H is equal to 0, 0 equal to this FBD1, isn't it? So look at here, this HV which is pointing towards the positive direction, so which will have the positive sign. And is there any other force? Yes, there is a horizontal force of magnitude 30 which is pointing towards the right direction, so which is have the positive sign, so 30 cos 30. So 0 equal to HV plus 30 plus 30 cos 30, which is 25.98. So this can be written as HV equal to minus 25.98 kilonewton. Since the value is in negative, so it can be rewritten as HV equal to 25.98 kilonewton in the negative direction. The arrow, you have to specify it. So HV has been arrived here. Next, I need to find the summation V value, isn't it? Summation V value. Summation V equal to 0. 0 equal to vertical forces. Look at here, VV, which is pointing towards the positive direction. So VV. And this 30 sin 30, which is pointing towards negative sign, so which is 30 sin 30, and VQ, which is pointing towards the positive y direction, so plus VQ. So 0 equal to VV plus VQ minus 30 sin 30, 30 sin 30, which is 15. So this can be written as VV plus VQ equal to 15. Let me just take this as equation number 1. So in order to find the unknown, I need to take the moment. So taking the moment about point V. So V is the point here, right? So in the origin, as you know that origin, there is no distance. So this HV and VV will not have any perpendicular distance, so that becomes 0. So summation MV equal to 0. So 0 equal to, let me just consider this 30 cos 30, which is horizontal, which doesn't have the perpendicular distance, so that becomes 0. So now look at this 30 sin 30, which is acting vertically downwards, which tends to rotate in the clockwise direction, which will have positive sign. So 30 sin 30 into its perpendicular distance from the origin, which is V to U, which is 2 meter, isn't it? 2 meter. Right. And VQ which is acting vertically upwards, which tends to rotate the object in anti-clockwise direction, which acts in the anti-clockwise direction of magnitude VQ into its perpendicular distance from the origin. So that is 2 plus 2, which is 4. So 0 equal to 30 sine 30 into 2, which is 30, minus VQ into 4. So this can be rewritten as 4 VQ equal to 30. Therefore VQ is equal to 30 by 4, which should be 7.5. 7.5, the unit you should remember it because it is everything is in kilonewton, so it is in kilonewton. VQ is in kilonewton. Got it? So now I am going to substitute this VQ value in equation 1. Substituting VQ value in equation number 1. So VV plus 7.5 equal to 15. So when I just take this 7.5 on the other side, that would be minus 7.5, right? So VV equal to 15 minus 7.5, which would be 7.5 kilonewton. Got it? Right. Next, I am going to consider the FBD2. Considering the beam 2. So for this beam also we need to apply the equilibrium condition. So, right. Applying equilibrium condition here. Equilibrium condition. So what are the conditions? Summation H is equal to 0, summation V equal to 0, and the sum of moment equal to 0. So summation H is equal to 0. Let me just try to resolve the horizontal forces here. 0 equal to the horizontal forces. Look at here. How many horizontal forces are there? Only one, which is HT, which is pointing towards the positive direction. So HT equal to 0. Therefore HT equal to 0. Let me just resolve the vertical forces here. So summation of vertical forces is equal to 0. So the 0 equal to, look at here, there's a VP which is acting vertically upwards, which will carry the positive sign. And that VQ which is acting vertically downwards. So minus VQ. And that yes, couple of forces are acting, which is vertically downwards, which will carry minus value. So 20 plus 20, so which is 45. And look at here, this VT which is acting in the positive direction, so plus VT. 0 equal to VP minus VQ value, we already arrived here, right? VQ value is 7.5, so 7.5 minus 45 plus VT. So this can be rewritten as VP plus VT equal to 45 plus 7.5, which is 52.5, right? So 52.5. So as equation number 2. Got it? So now I'm going to take the moment about T. The reason why I'm just taking T, because if I take the point T, this 2 becomes 0, because in the origin there won't be any distance. So taking moment about T. So sum of moment T equal to 0. So 0 equal to, look at here, this HT and VT, they don't have the distance, the perpendicular distance, because this origin is 0. So this becomes 0. Now look at here, this force which is acting vertically downwards, it tends to move the object in anti-clockwise direction. So which will have minus 45, there's a force, and the distance from the origin is 1. So 45 into 1. Let me just move to the next force, which is VQ. VQ value is 7.5, which is 7.5 kilonewton, isn't it? So 7.5, which is acting in the negative acting in the negative y direction, that is vertically downwards, and tends to rotate the object in the anti-clockwise direction, which will carry minus sign. So 7.5 into its perpendicular distance from the origin is 1 plus 1 plus 1, which is 3. Got it. Let me just move to the next force, which is acting vertically upwards, which tends to rotate the object in positive direction. So Vp into its perpendicular distance, that is perpendicular distance from the origin, that is 1, 2, 3, 4. So 0 equal to minus 45 minus 22.5 plus 4 Vp. So 4 Vp equal to 45 plus 22.5, which is plus 22.5, which is 67.5, right? 67.5. So Vp is equal to 67.5 divided by 4, which works out 16.87. 16.87 kilonewton. Right. So now this Vp value can be substituted in equation number 2, where it says Vp plus Vt equal to 52.5. Vp, substitute Vp value in equation number 2. So Vp value is 16.87 plus Vt equal to 52.5. Vt equal to 50.5. Equal to 52.5. So Vt equal to 52.5 minus 16.87, isn't it? 52.5 minus 16.87, which works out 35.63. 35.63 kilonewton. So at last we'll have to mention the result. So which is HV equal to 25.98 kilonewton in negative direction, isn't it? Next, the VQ value and VV value. So which is VQ equal to 7.5 kilonewton and VV equal to 7.5 kilonewton. Then Vp equal to 16.87 kilonewton, isn't it? And Vt equal to 35.63 kilonewton. Right. When you have such problems, there is a combination of the beam, that is two beams are there and which is supported by, in between the beams there is a support, there is a roller support. Then you'll have to consider this and do two FBDs. First, the UDL or UVL, whatever the loads are there, that needs to be converted into PL. Then you just start drawing the FBD and considering this is FBD for beam 1 and FBD for beam 2. Then you just look at the FBD where you have the minimum unknown forces. From there you will have to start solving it, and by applying the equilibrium condition you will arrive the value of the unknown reactions. Hope you have all understood how to solve when you have such problems. Thank you.